Welcome to adding security to your architecture one step at a time. I'm Warren Parad, and I'm the CTO at Authorus, which is a SaaS product for that provides user authorization APIs for specifically software makers. Additionally, user identity, authorization, access control, and authentication to help overcome security challenges in architectures and platforms. Before this, I worked at a number of companies building distributed architectures and platforms, helping them overcome some of those same security challenges. I'm going to pull from my experience today and share some of that advice that I normally give to overcome these issues, building blocks, security, you name it. There's a lot that goes into security, so much so that if I were to list all of these out and more and talk through every single one of them, we would be here long until the conference was over. The truth is that security is hard. It's not a very simple thing to do, but I'm hopefully going to be able to walk you through it. Specifically, there's one key takeaway for today, and that's a bit of a learning on what some of these security building blocks are, and more importantly, when to use them at the right time. And as Agilists, we know doing the right thing at the right time is a great way to add value. Unless you're not an Agilist, and then I'm not sure what you're looking for at this conference. Just as a reminder, this is the QR code for asking questions. I'll give you a minute to scan it. I have seen in previous presentations people taking screenshots of the slides. Don't worry about taking pictures. There's actually a slide all the way at the end with another QR code on it, because I know everyone loves QR codes, with a link to this presentation. So afterwards you can get at it. And there's a simple URL as well in case you don't have an app on your phone. I don't know who doesn't have an app on their phone to do this, but I've been told that apparently it's the case, especially if you have an old one. So you can figure out that lots of things can be done in this space. And one of the opportunities is to add security all the way at the beginning, long before you started building anything. You can start talking about security. You can start asking questions about it. Who are our users? What sort of data will they be giving us? Is that data regulated because of the country it comes from? How do our users access our services? Where should our services be deployed? These are all things that you may need to answer. And while you don't have to do it at this moment, doing it at the beginning helps you for when you have to do it later. You don't have to have the answers immediately, but if we're not talking about it and not asking questions, then there's no way we're going to start doing the right thing one day automatically. Now, you may notice that at the top of the slide here, there's a little indicator. Just on some of the slides, it shows how easy this particular thing is to start doing and when you can potentially start doing it for your architecture platform for your software. So you started thinking about it even before you started building, but at some point you're going to start building something. You got to deploy it somewhere. You can deploy it just to your local machine. I don't recommend that. Or you can deploy it in the cloud. There's lots of cloud providers out there, and they offer lots of tools that we'll see now and going forward that help you overcome some of the common security issues. Why not deploy it on your machine if it's easy? Well, at some point, you're probably going to have some production users, and you'd have to poke some holes in your firewall, some in your network. And I don't know about you, but I don't want to have people on the internet coming and accessing software I'm running on my machine. I don't trust everything that I'm running today. I don't know if you do. And I don't want to open my firewall up to potential malicious attackers. But you've got something running in the cloud, hopefully, and you're going to want to start securing it. I recommend starting with encrypting the traffic, or encryption in transit. And you can do this by adding TLS certificates directly to your application via your cloud provider. Most cloud providers offer an easy, simple click to do this. A couple of clicks in the UI and you're done, or some complex IAC, infrastructure as code, to get it deployed. If you're not using a cloud provider, then you're going to have the struggle of doing this on your local machine or your local data center. While there are tools available to do this, it's not as simple. Not to mention how to handle some of the more complicated aspects, like what do you do when your certificate expires? And what versions of certificates do you use? They're always rolling, new encryption mechanisms are available. So the data coming in now is potentially encrypted, and you can start letting your users in. When you think about users in your software, what do you think? Maybe a username and password in your database. And there are even some SDKs out there that will help you store users and usernames in your database. But there's a lot of extra complexities that they can't help with. Everything else that comes with identity, and that's maybe two-factor authentication, how you can configure emails to send out to your users when they log in, or SMS, or WebAuthn, federated identities, or account hijacking. How are you going to handle that? Will the SDK do it for you? I recommend at this point to use an identity provider. Your cloud solution will offer one for you usually. And if you don't like that one, there are login with Google, login with Azure or Outlook, or one of the social providers that help you overcome some of the complex issues that come with identity. So users are coming in to your software. They start using what you've got. That means they're giving you data. It's time to encrypt that data. What does that mean? Well, cloud providers offer a way to encrypt at rest, full drive encryption, out of the box, almost by design. If you're doing this on your local machine, you can get it done. Good luck. Maybe you need something a little bit more complicated. Maybe you need blob level encryption, row level encryption, field level encryption. Cloud providers offer that. You got to think about those questions we were asking at the beginning. Is it regulated? What sort of data is it? Now that we've asked those questions, we can think about, okay, maybe we need to start doing this. Good thing we asked them. We have the answers now. We started with the mindset of asking those questions. We can move on to having a team that supports your software, however it's running. So you have a couple of engineers that are running and supporting your software. And at this point, you can think about what are their expertise? So you may have someone on your team that's deep in quality or deep in user experience. It's time to have someone that's curious about security. You can't start implementing all these things that I'm talking about here without having someone that's at least potentially curious about security. And when you get them on board, the first question they're going to ask you is, where are my tools to do this? How do I do this effectively? And that's the time to start logging everything. Log all the requests that are coming into your application and what those requests mean and how they work. What are is it a successful request? Is it a 500 that you service through an error? Or is it a 400, 403, anything like that? This data will help you validate what's happening later. I put a little asterisk here. Please do not log your username and passwords from your users at any point. Someone's going to end up doing that, and you don't want to find out through social media that this was your company, and you'll have to issue one of those dreaded security disclosures to everyone. It will probably damage your brand. This is a good reminder. Don't use username and passwords. Just federated providers, and you won't even have this problem. While you still have to deal with credentials some of the time, you've just eliminated a whole class of potential issues. As your software grows, you may have different kinds of user roles and different kind of data that you're getting in. You're going to want to think about the access patterns for that data. Does every user get access to everything? Well, maybe we ask the question, is the data public for everyone to see, something like a social media platform, or is it private to a specific user or a specific set of users? Is there more than one user in an account? Do those users need different levels of access? Because we implemented an identity provider early on, now we can just build on top of it with access control. Lots of them offer this very easily on top. If we're stuck with our SDKs, they may not provide exactly what we need, and that means building something else or pulling else in additional complexity. At this point, I want to caution against using giant frameworks that purport to solving all of these problems. At this scale, you may have a micromonolith, some software. It's not quite grown that much, but it offers the critical features that you need to prove that you've got something that works. These frameworks may say things like they solve your presentation layer in your UI, as well as the business logic, and also interacting with your database. They handle everything for you. And if you're a framework expert, this may exactly be what you want and may help you get to this scale. But let me ask you a question here. If you're using a framework or you think you're using a framework, does it have CORS enables by default? That is, cross-origin resource sharing. Is it enabled by default in the framework? Did you enable it in that framework? And does your application actually need it? I find that lots of implementers of these frameworks can't answer those questions. Maybe they played around with some flags until it just started working, and that's how it's been left. Often it's the case, and you wouldn't be able to say at this moment, are your endpoints secured by default? If you added a new one, would users just be able to come in and use it? Or is the appropriate security added? I want to take a moment here to think about how the complexity of your software grows over time. If at this point we have a micro monolith, at some point it may grow to be a giant ball of mud, or a well-oiled monolith, or maybe you're thinking about separating into microservices. I think it's an interesting point to realize that the architecture we pick actually influences the security we add into our solution. Think about that for a moment. The architecture that we're picking has security implications. Okay, well, what sort of security implications? For instance, if you've picked microservices, you're going to realize very quickly you need to deal with service-to-service communication. You can't just leave it open. These are separate services. So I'm going to add in some sort of security here. An example would be asymmetric private-public keys. That is, the calling service encrypts or signs a token and sends that token to the recipient service to validate it. This is the best way to secure it. You may be thinking shared plain text strings. I saw someone laughing. It's done, right? One service takes a secret out of memory and sends it to another service, and that service goes and validates that same string. You may even store it as source code. Hey, it's fine, no big deal. No one's going to see it. But that will end up in your logs one day. And it's more powerful than a username and password, where you at least didn't store it in your database in plain text. You salted and peppered it and potentially hashed it, hopefully. If you're not using microservices and you're using some sort of monolith, then you're probably not thinking about that communication between the different components. But you are probably thinking about, how do I secure it from the outside? And you may have created a distinction that some of the components need to be behind a special firewall or in a special network that nothing else can touch. Well, here's a question. If part of your monolith, one of those components, gets compromised, is your whole system compromised? I would have to say yes. Now, maybe you say, I don't have service-to-service communication in a monolith. I just interact with the database. But if one of those services, one of those components is compromised, that means your whole database is potentially compromised. All your services, everything you've got. So while we don't have to say that one architecture is better than another one, because we picked microservices, we're inherently shown that here's an example security problem that we have to deal with and solve. And that same problem exists living in the monolith world. But we didn't think about how to solve it. Using microservices told us that. What do we do with those asymmetric keys that call different services? That's a secret. Well, we should think about how to encrypt them. So before, while we were talking about encrypting data, we should think about how to encrypt the credentials. I recommend sealing them and putting them in source code. That's encrypting them and committing them directly to your Git repository. It's an easy thing to do. Cloud providers support it. You may think about using a third-party tool or another repository to store your secrets in, but that just amplifies the number of places where your secret lives. So think about where they can be accessed, how they should be used. Having them only available in production limits the number of places that they can be, and you don't have to worry about accidentally logging a secret that can be used with any service in your whole platform. Okay? So we thought about security. We had someone on the team that's curious about security. How do we deal with our growing platform? We should probably have some security experts on our individual teams, directly embedded in the teams whose primary responsibility is security. I may call them staff plus engineers. I bet some of you in this room, that is you. You are that engineer for your team that's sharing and cross-pollinating that knowledge for other people as well. I think this is an important aspect. We're not going to be able to get very far with just knowing about a list of technical concepts and throwing them at a wall and hoping they stick. Someone has to be responsible for at least making sure that they're there. Well, what goes along with expanding the mindset? That's doing something with our logs. We've implemented them. Now we have lots of logs. We can potentially automate. We can add some active monitoring. There are tools here to do that, and alerting. When we get more authentication requests than we're normally used to, what does that look like? Is a user trying to get in, an attacker potentially? If we have monitoring, we can compare it to a baseline. Are there less authenticated requests than usual? Did we change something in security that potentially broke our platform or software? This is a great way to identify it. You don't have to go much further than that, but this is a great start. Now, if you're feeling fancy, you can take another step, and that's using a web application firewall. This is an example of something that would come with some default rules as well as ability to add custom rules. Something like, does this request look a certain way? I don't even want to let it into my platform. Now, you would think, why do I need this? I can just block these requests directly. Well, I've heard that there are unsecured endpoints on the internet that bots roam around and are looking for them. You may see something like WP admin PHP as one of your requests that are coming into your software, even though you're not running WordPress. Well, it turns out that there's unsecured WordPress installations, Mongo installations, Elasticsearch, and these bots are just out there crawling the internet looking for these potentially insecure endpoints. So they're hitting your service and checking. If you're running one of these pieces of software, then they're going to find it. It's going to happen automatically. Rules like this that are provided allow you to block these sorts of requests. You don't even have to think about them. If you want to take this to another level, you can go even further and take those logs that you've been generating and filter them for requests and use them to power your dynamic rules. This sort of header looks in a particular way with a particular token. Well, we know that's a legacy request. We should just block that. An old user from 10 years ago is trying to get in still. Maybe that token's been compromised. You can add a custom rule for that. Or the request is coming from an IP address that we know has only attackers behind it. I wish this weren't the case in 2022, that IP addresses mean anything, but it does still turn out that lots of malicious requests come from the same block. So adding a rule against that can really be helpful. You may get to the point where you need to expand your software even further. If you're running in a local data center or in a single region, and you start getting users that are from a completely different region, you're expanding out your business, they're going to have a bad time with performance. They're going to go through a complicated network and end up in a single location. So why not duplicate that infrastructure somewhere else? If you're not running your software in the cloud, running your infrastructure in a completely new location is not a trivial challenge. It's incredibly complicated, so much so that there's whole multi-billion-dollar businesses built on this idea. If you want to take up and move to another location, then you're going to have some troubles. An example is just the physical security aspects. It's not easy to secure a physical building. There are security professionals whose job it is to break into these buildings. And if you're really interested in this topic, there's white papers from every single cloud provider that explain how they manage security physically at their data centers. So if you're interested in building another data center in a country that you haven't been to in a long time, but because you potentially have users there, you're in for a great experience. At this point, I want to be careful about mentioning cloud providers, because if you're using one, then you're gonna see that there's lots of great tools that's there. But those tools may seem so great, you're tempted to use them everywhere. And the tools that they provide are focused on what I call cloud security. That's the security of your cloud provider's control plane, the one that your engineers interact with. So your engineers day-to-day are building infrastructure in your cloud provider, and that generates all the services, virtual machines that you need. The tools that they offer allow you to detect when unauthorized changes are happening in your account, block or change or restrict access to different kinds of engineers. And it may be tempting to use these same tools in your application for your own users. You want to be careful about avoiding to do this. These tools are not built to be able to support the same sort of scale. An example would be just your users that you have may be many magnitudes larger than the number of engineers you have to support it. So you can imagine that there's an extra level of complexity here that doesn't exist for the tools that they're actually providing. Okay, so your logging's increased in complexity as you added additional tools upon it. Your infrastructure has become larger. You may be in multiple regions. The security tools and strategies that I've shared with you up until this point have become more advanced. You probably have multiple teams to support all the software that you're running at this point. That means you need an improvement to your mindset as well. Whereas before we had security experts throughout your teams that were cross-pollinating, you need to think about how to extend that to support the whole team in general. I recommend the idea of every engineer is responsible for security. What does that mean? Well, you can have an individual team somewhere that's there that helps train and grow engineers so that they understand the critical aspects that we've set up here. But if you have a centralized team, that means you have a centralized knowledge about how security works. And fundamentally, whether your software is secure is going to be a matter of whether or not the components that your engineers are building are secure themselves. In order for them to have that knowledge, they need to be thinking about it and working through it on a potentially daily basis. Don't rely on a central team to handle all of your security needs. It's not going to be a great experience. I'm tempted to say something about Conway's law here, but maybe I'll hold off on that. I want to revisit what we've talked about so you can sort of see some of the patterns that we have. I talked about all the way at the beginning asking the right questions. Then the mindset grew to having someone dedicated who actually is curious about security. And that's moved to multiple engineers who cross-pollinate security ideas within your organization. Finally, to the point of everyone's responsible for security on your teams. With encryption, you can start with a simple encryption, end-to-end encryption of using TLS for certificates, and encrypting your data where it needs to be encrypted for users that need to be encrypted, if that's regulated data or you want to protect in a number of different situations, to encrypting your credentials. With logging everything, you can add monitoring and alerting to that, and finally throw a WAF on top of it to block every kind of a request you can possibly imagine, and with managed rules, hopefully requests that you also can't imagine. On the path of identity providers, something to manage your users' identities, add complex access control, handle service-to-service communication very easily, and then managing potentially even access to third-party services. The same way you have communication within your services, you may need to communicate with third parties as well. Additionally, there's the infrastructure components and the architecture. Now, I have that here. I think this means a lot of different things to lots of different people. The number of talks that I've seen makes me think one thing is for sure in this conference, and that's we all mean something different when we say architecture. Hopefully some of these ideas help you secure whatever it is that you're building. This is me, and if you're interested in connecting, you can. And I did promise that the slides at the end would be here, and here's your QR code if you wanted to scan this. So thank you. That is the full extent of my talk. At this point, oh, sorry, you were going to say something.
Yeah, well, thanks a lot. We have not a question at the moment in Slido. So is any question there in the audience at the moment? Somebody curious about how to encrypt the traffic? Not yet. Okay.
If no one asks a question, then I came prepared for this exact moment, which is going to force participation. And that's which cloud provider's IAM service can be used to support your software security needs. How many of you think that Amazon offers an IAM service for you to do this? How about Google Cloud and Azure? Now, see, that's an interesting aspect because none of these providers actually offer you an IAM service to support your needs. They do it to protect their cloud control plane, but none of them offer the service at a level that you can use it to secure your actual application. So that goes back to thinking about what tools are the right ones for my actual needs. Just throwing an arbitrary tool at your problem and hoping that it's the right solution just is a potentially amount of security theater and doesn't actually help you protect your architecture, your platform, your software from potential attackers. Being deliberate is an important aspect. At this point, I'm hoping that there's...
Yeah, there's one. Let me just...
You don't need to use Slido. You can feel free to raise your hand.
Yeah.
About putting the keys, the encryption on source code.
Yeah.
So the vectors are not sometimes higher, like everyone in the team or in the organization sometimes can access it.
I'm not sure I totally understand the question.
You say we put keys on our source code.
Yeah.
So those are used for data encryption, right?
I mean, you can have keys for any number of different reasons. So if the question is why do I have keys in my source code?
Yeah.
Okay. So I may have to, in a service-to-service architecture and multi-service or even in a monolith, you have to secure the communication between two different services. Well, how do you secure that communication? One way is to have the client service sign the payload request that goes to the recipient service, and that recipient service can verify it. So how do you actually handle that communication? One way is with a secret. So you need to have that on the client side, and if you use asymmetric private public key encryption, then the recipient side can have a public key. So that private key on the client side, you need to secure it in some way. So when I want to be careful, I didn't say put it in source code. I said seal it in source code. I would expect it to be encrypted and then stored. You don't want to put it in plain text because anyone who sees that key then can leave your company and have access to your services, which because we put them potentially on the public internet means access to all the data that's there. Does that answer your question? Mm-hmm. Yeah. Only no. You can.
We would need to repeat that probably. So you said that the public keys are the ones that are on the source code repository to encrypt the traffic. Is that right?
You can seal your private key in your source code by encrypting it using yeah.
Sorry.
Yes. Yeah. Okay. So you don't want to take your private keys, your secrets, and put them directly in source code. You want to encrypt them before you stick them there. And if you do that, then your source code offers you an audit trail for whenever that changes and the easy ability to actually change it. It also limits the number of places that your credentials are, because if you put a credential in Vault or something, now you've exposed your credential in 2 places. Well, 3 if you count where the credential came from. The source of the credential, the user of the credential, and now a third system. If you seal it in source code, it only exists in now 2 places: where you got it from, which hopefully threw away that key, and in your source code only to be used as production when it's actually decrypted. If you're using a private public key pair, you actually can get it down to 1 place if the developer that created the credentials uploaded the public key to the recipient service. Now it only exists in the production runtime of the software and nowhere else.
Okay. We've got one question in Slido, and then I will come to you with the microphone. What is the best way to secure my monolith if not through an external firewall? What options do I have?
Well, the truth is that you have multiple components in your system that are communicating with each other. So there's no difference between having a monolith or having microservices when it comes to needing to secure service-to-service communication. So the same strategy that we had with microservices we can use in a monolith. And if you don't have any communication in your monolith, then you don't need to secure the service endpoints, but you still have the problem of the idea of a monolith is probably, maybe I'm going to go out on a limb here and think that it's multiple services accessing the same database. In which case, there's no way to secure that in a reliable way other than first separating out that communication. Because if a service becomes compromised, then the data in your database becomes compromised, therefore compromising every service, even without going over the service endpoints.
My question is also communication, authentication between the services. And assuming we are completely on Kubernetes and having amount of services that we want to authenticate differently. Agree with public keys, like what you would do first, but would be service mesh potentially be the next level of this? Or what would be interesting in your opinion on that? Or maybe a comment.
Okay, there's a lot there. I think the question is, should we use a service mesh for security? I could say something like no, right? that can be my answer. The truth is, it's one of those things that I don't list here because the management of it is incredibly complex. Multitudes bigger than Kubernetes, which is already a huge ask on lots of teams. If you want to have security, you do simple things, not more complicated. Now, there's this idea of we want to limit the requests that go between individual services, and we want to secure that communication. Instead of using private public keys, we may say we use private public keys, but we do it over MTLS, which is basically saying we use private public keys, but do a complicated TLS thing like websites work, which if you don't understand what I just said, that's the point. To take it another point further is it doesn't help resolve the problem of can I do this thing, right? If user identity is who I am, the service is the machine, I am this machine, I am this service, it doesn't say what I can do, which data I can access. So you still need to define that somewhere. And in Kubernetes, you may be tempted to use your configuration to drive what that is, although that's usually a business problem, not an architectural, not a technical one. So you want to segregate that out and let the service's responsibilities and access be defined outside of that system. Plus, the protocol you're using to communicate between services isn't going to know why that request is being made. It's just going to know that it's being made. And unless you give it access to intercept your encrypted communication and parse that out, which would defeat the purpose of having the service mesh in the first place, it's not going to be able to do that validation anyway. So no, I don't think service mesh solved that problem.
Okay. Any other questions? Over there?
Or you can scream loud.
Yeah, no, because it's not on the video. I'm sorry.
Ah.
So regarding your mindset questions,
yeah.
or your points, you have any quick tips for sparking curiosity with security and also how to kind of cross-pollinate without turning it into a chore that developers really don't want to be involved with?
Yeah. How do you spread the security mindset throughout your organization without it being a chore? Well, I think like lots of things, and I can't believe anyone would want to be a UI developer, but they're out there. So there are apparently. So there are people that do care about security, and I think it's about bringing some of them into your organization and focusing on those aspects. Obviously, there's a component that's top down. Your organization can't just say, we care about security, because that's like what every company says. We care about security. I mean, but do they actually? Are they taking the steps to empower people to ask those questions and to answer them? Depending on your size of your organization, you can also go to the extent of having red and blue teams and other complex practices to stimulate them. For instance, running some sort of capture the flags inside by saying, oh, here's an example of servers that we can have. Can you break into them? And rewarding them. I often have run those sorts of challenges in previous organizations to help with that. But the truth is you need to have people that are empowered to think about it and actually want to. And so back to your question of, how do you get them to actually be curious about it? Well, I find that there's a lot of overlap between, especially the things I talked about, and product features that you have, like user identity. Where is the user identity? Well, now you know something about security in software. I think when you're implementing user identity, it's like, well, wait, I heard maybe I shouldn't use an SDK for this. Maybe this is the time to spend investigating some more about it. I think just sharing that knowledge is a great start. I think there's a deep embedded question there of how do I motivate people, which I'm definitely not going to answer right now. Does that answer your question? Okay.
Okay. I'm a little bit from the off now for the camera, but I think we thank you a lot for answering questions and your talk. Yeah, thank you.